Hi, my name is Christopher Erdman. I'm here to talk to you about 5 tips to citing your research software and improving discovery. I am with the AGU data leadership team, and together with my colleague Shelley Stahl, we put together these slides to help you through the process. So to begin, an overview of software citation tips. We'll be covering software management plan, choosing a repository, preparing your availability statement, including software in your references, and instructions for people on how to cite your software in your favorite development environment. So to begin with, though, I thought we should start with giving just a picture of why software citation is so important. So to begin with, some examples from Twitter of researchers talking about this, the challenges. In this case, this researcher has actually developed an RStats package and has many downloads, 11,000 downloads, but 0 citations, and is expressing the frustration of the fact that the citations are not showing through in addition to the downloads, and sort of receiving credit within the academic system for the software they developed. Next, we actually have another researcher talking about the challenges in developing the software, and in particularly for early career researchers that are often developing software that also don't get the credit for this work in the academic sense of getting citations. So this is another challenge that you hear from the community. And another one is finding software. Searching for software is very difficult. It's linked to within papers, and so you have to search through the literature to find software. And so citing software could actually improve, at the end of the day, could improve discovery as well. So what are we talking about here? Not just software, but code, workflows, the models that you're working with, all that's integral to your research. And so to start, I mentioned this first point of writing a software management plan. You may have heard of data management plans. Well, there's software management plans. In a similar fashion, software management plans allow you to sort of think ahead of time about your project, how you structure your software, and how do you prepare for these cases that will arise. And in this case, there is a guide from the Software Sustainability Institute that walks you through some of the things to think about as you're putting together your software management plan. And one of those things, just an example here, is choosing a license. So oftentimes researchers, you get into the work and you forget to actually choose a license ahead of time. And I think then you're ready for publication, and then you have to choose the license that you want to use. And so thinking ahead of time could really avoid the scrambling that happens at the end when you're ready for publication. And it also allows others to understand how they can reuse your software. So another point to make here is choosing a repository early on. So the software development environments that we use often when we're developing software are very helpful. And one of the examples is GitHub that people often use, but they're not long-term solutions. They're not preservation solutions. So we encourage you to go out and look at repositories that are out there that make sense for your software. So to start, the institutional repository at your local university or research organization. There may be a software domain repository, and we have an example of HydroShare as one example. And then there's the general repositories supporting software preservation. And one of the favorite examples there is Zenodo. It's often used by researchers for preserving their software. And again, this is what happens when you don't preserve your software. If your repository is moved or it's removed, then you get these 404 errors and other situations that arise. And we want that software, that link to remain, to be preserved, so others could access it at a later date when they're trying to understand your research and reproduce it. I mentioned earlier, there's this popular method that's used. So between GitHub and Zenodo, a general repository, where you can actually use a release mechanism within GitHub to release versions of your software through a web API hook that automates the process of moving all your code and other related items, your documentation, and so really streamlining that workflow for you so that it ends up in Zenodo. And one of the things that we note here is that when you're doing this mechanism to bridge basically GitHub and Zenodo, to remember when you release your software, author names, so your username in GitHub is often transferred. The title keeps the title of your code that you've named. And so, giving meaningful title in addition to the name of the code is useful. The context, basically, for helping others understand what your software does. And the versions, of course, are very important as well. So version 1, 2, 3, 4, 5. And another useful tool in this workflow is a sandbox that Zenodo offers, which allows you to actually test this workflow out and see how your metadata is described when you're depositing. Even for other repositories, this is a useful tool to understand really how to describe your software at the end of the day, what ends up in the repository, and how do you make it more meaningful? How do you help others reuse it or understand it better? So this is a very important tool as well to help you in describing your data. It also streamlines other things that help you with your metadata within your GitHub repository, your development environment. So one of those things is called a code meta file. It's a metadata file that you can include in your repository, and it follows your repository and helps with describing it as well. And one of the other things we like to point out here too, important things to remember is within the metadata, there's a related identifiers field that allows you to link your paper to your software and also other research objects that are important to your paper, to your research. And so that's another thing to not forget when you're depositing your software. Next, the next step, the next tip that we have is to prepare your availability statement. So think about this ahead of time, what you will need when you publish your software with your paper. And so availability statement, we've narrowed it down to some of the key things that you need to know. One of the things, deciding, is the software important? Has it had a significant impact on my research? Is my research reproducible without it? So these are sort of key questions to ask of, do I include the software in my availability statement? These other items here, so going down the list, providing a brief description of what the software is used for. The other thing is a persistent identifier that you use when you're depositing your software in a repository. So another example here is Zenodo. It offers a DOI that you can link to, the version of the software, a license. We mentioned that earlier, is very important for people to understand if they can reuse your software. And then other access conditions. Sometimes, we encourage open source licenses, but that's not always the case. And there's a gray area as far as software sometimes. And sometimes there are access conditions for that software. Sometimes you need to request access, or there's potentially a fee sometimes, or there's closed access. And so sometimes that gray area, you need to explain the access conditions for others as well. And then the development platform link, again, the popular example of GitHub, linking to where your software resides in a repository on GitHub. And then a methodology section of your paper, describe how your software works as it pertains to your research. So the other thing to note here is people often ask, well, do you have an example? And here's an example statement template. So version number of the data cleaning and analysis software used for this research is preserved at, including the persistent identifier link, available via license. So an MIT license is maybe a popular license to include here. And then those access conditions that we talked about earlier, and developed openly at, and the GitHub environment could be where you link to here, the repository where your software is. Another thing to consider here too is that you need to include the software in your references to cite your software, so you ultimately get credit for that software. So these are some examples that we found in the software references in AGU. And you can already see some of these examples need some improvement, but it's great. We have some examples now. We have some people sharing their software, including it in the availability statement and their references. In this case, the author names are correct, but the titles could use a little bit of help. At least for the first case, the title could use a little bit more context. And the use of master here is something to maybe avoid as far as inclusive language. A version number would have been more appropriate here as well. And then you have the persistent identifier, the source Zenodo, where the software is preserved. And you can see below there's some other examples that do include a little bit of context of what is included in the software package to give a user sort of an understanding of what that is. Sometimes, in some cases, the software is included with other things, and so sometimes you have to really describe what's in that deposit to give the user a better understanding. So a last tip, the fifth tip here is add instructions to your development platform on how to cite your software. There's sort of a spectrum of examples that you see out there at the moment. You have a citations file in some cases where a citation is included in the file, but it's not necessarily machine readable. Another case, you can see citations on README files. Again, not entirely machine readable, but it's great that they're mentioning how others should cite their software. One way that you can improve this is to use a file format called .cff, the citation file format. And there is a helpful website out there, the citation file format, the link below, that walks you through sort of the process of creating one of these files. And later on, this will become more and more important as things become automated. Systems can go and extract how you want your software to be exactly cited by linking to the repository and other ways to your preserved software. And so this is a very important piece as well to remember as you're thinking about citing your software. So at the end of the day, benefits of citing your software. We mentioned you can get a persistent copy of your software that supports the reproducibility of your research. It cannot be confused with other versions or copies. So it's like this frozen in time record that you can always go back to as a particular release or version that you cited and you connected to the research in your paper. Increased discoverability, awareness of your work. Mentioned earlier that it's hard to search for this software at the moment, to find it, and for others to sort of take advantage and potentially collaborate with you. So discoverability is improved, and then tracking the citation, tracking that and giving credit at the end of the day. And you saw those sort of early examples of people expressing frustration that the software citation is not being done correctly and not entirely. So at the end of the day, you can receive credit for this, which I think will be great for researchers. So to close, again, I'm with the AGU data leadership team, and my colleague Shelly Stahl and I thank you for your time. And we hope this helps you in your quest to cite software and improve discoverability of your software. Thank you. Bye.